He came along with you. He also goes to Riyadh, and then your mother also is also working here, or
My mother is not working, my father is working.
okay, okay. So let's start. So rate of reactions we have done. Uh, I ask you that is there any specific topic that you are missing? So did you ask the teacher that that is periodic classification of elements is coming or not coming? I told you that when you went to school that you were going to ask it from your chemistry teacher.
Classification of elements, that is in like very old chapters are it's not coming out, I think.
Okay, so let's start doing the Nabeel, let's start doing the question that we were discussing earlier also. Okay, so just give me a minute. Let us start doing. In how your others subject preparation is going on.
I haven't started anything. I
If
have
I
1 month.
You have 1 month and you can do it all in a month. You are
Yes,
you are having a confidence.
it's less than 4 days to study each subject.
4 days to study each subject. Okay, so just a minute. I'm just opening the question paper. Okay, so it is from 23. Today we're going to discuss the theoretical questions. So is there a separate question is going to comes in your examination like question paper for the chemistry, or there will be a single paper containing both MCQ and the other we have that is in
Uh,
subjective and
like MCQ sheet, the question paper, all the questions will be in one paper. MCQ sheet will be different.
MCQ should be.
The MCQ questions will be with the normal questions, but the sheet in which you have to take it will be different.
The element X undergo the physical change. So tell me
X
what is that called?
element X goes into physical change.
Solid to liquid is called
Now, okay, each physical change. Solid to liquid is called melting.
yes. Liquid to gas,
Liquid to solid is called freezing.
then
Liquid,
solidification. Solidification. Yeah, freezing, but use the
sorry,
word better word solidification.
yes, yes. Liquid,
Okay.
okay.
Then
Liquid to gas, evaporation.
liquid to gas is evaporation. Okay. We
Gas
use
to liquid,
not
condensation.
evaporation. We actually use vaporization. The better word for this one is vaporization.
I thought they are both kind of same.
Evaporation. Okay. You can consider this one, but evaporation and vaporization means converting something in the liquid state, from liquid state to gaseous state, either by boiling or by evaporation. That is called gaseous change. Okay. Now from gaseous to liquid,
Yeah, from gas to liquid, condensation.
condensation. From gas to liquid is very good.
Con-
Condensation. And from liquid to solid, we have
from
done this
liquid.
one. And from solid to directly into gas,
Okay, wait, I know this one. Solid. It's a long word.
okay, I'm going to. Complete it.
Subtraction. What? Wait,
Sub.
wait.
No, this word I have just dash. Complete this word.
Sublimation.
Sublimation.
Okay.
And from gaseous to liquid. Sorry, gaseous to solid.
Gaseous to solid. That I don't know at all.
Okay, what is it?
Eh, Deprivation.
Deposition.
Deposition.
Okay, do it. Note it down in your notebook, please. Not only this one that you don't know, that solid to gas and gas to solid.
Okay. Wait, why are we doing this? Like from full starting?
Yes, we are doing it because it is a new paper that we are solving.
Okay. Okay.
Done.
2 minutes.
Done.
Yes. Done. Done. One difference between boiling and evaporation is the rate at which the process occurs. State one other difference between boiling and evaporation. Evaporation doesn't require external energy. It
Hmm?
happens from evaporation doesn't require external energy.
Why it is not required? It's taking the heat from the environment. Require the wind energy.
No,
Heat you are
like
talking about, that it can occur at low temperature. That's why you are saying that it does not require if you. If you keep it in the solar, in the sun, so it can easily take place. You are thinking so? No, it is not so. Evaporations, when,
For boiling, it needs a specific temperature, 100 degrees Celsius, which is
yeah,
boiling.
yeah, you
Yeah.
can say that evaporation can occur below the boiling temperature, while the boiling will always occur at boiling temperature. Okay. Evaporation is a surface phenomena, while boiling is a bulk phenomena. Okay. Understood?
Yes.
Describe the
This
separation and arrangements and motion of particles of element X in the solid state.
separation, arrangement, and motion of particles. Wait, let me tell arrangement. They are tightly packed together.
Describe the separation, arrangements, and motion of particles of element X in the solid state. Element
Yes.
X in the solid state.
Let me tell from arrangement and motion first. So arrangement of element X is that it's tightly packed together.
Okay,
All of it
separation.
tightly packed together. Motion, it vibrates in place.
They vibrate about their mean position.
Yes.
And they have very
So,
less kinetic energy. And separation, they can be separated by applying heat. Okay, latent heat.
yes.
Yes. Magnesium, calcium, and strontium are group 2. Now this is a from the C part of this one. Calcium react with cold water to form product. A colorless gas P, which pops with a lighted splint. Okay, when means we bring a burning candle still toward it, it produce pop sound. So tell me,
React with cold water to form two colors. Colorless gas P which pops with a lighter splint. Hydrogen, a weak a weakly alkaline solution Q is turns milky and carbon dioxide is bubbled through calcium oxide.
identify the ions responsible for making solution alkaline.
Mm,
So weakly alkaline solutions Q turns
mm,
when so it is saying calcium when react with cold water. So what is the reaction when calcium react with cold water? Tell me.
Calcium react with cold water. It produces hydrogen gas,
Okay,
uh,
calcium when react with water, it will produce hydrogen gas plus
CaOH, calcium hydroxide.
CaOH. It is the correct formula. Bill,
Uh, CaO, calcium oxide.
CaOH whole twice.
Uh,
Okay. Identify the ions responsible for making the Q solution alkaline. It is the hydroxide ion.
okay.
Okay. So this is the Q solution, which turns milky when carbon dioxide is passed through it or bubble to it. So when you have calcium hydroxide and you pass carbon dioxide to it, then what would happen?
Carbon dioxide. It turns milky.
Okay, it turns
Milky.
milky. Okay. And why it turns milky?
Yeah, because
And why it turns milky?
carbon dioxide is reacting with CaOH.
Yeah. So it form what it form? It form calcium carbonate, CaCO3, which is solid, which form insoluble substance and water. And because of this calcium carbonate, it which form white precipitate. White precipitate,
Precipitate.
do you understand? Precipitate means
Yes, yes. I understood.
formation of some insoluble substance that does not dissolve. Or anything that does not dissolve in water or anything, it will show its color because it is not going into the intermolecular space. Na?
Yes.
Okay, like sodium chloride is white in color, but when you add it, it's it is colorless. When you add it to water, it will become colorless because it goes into the intermolecular space. But if you start adding chalk to the water, it will turn as milky due to the
Okay.
formation of calcium carbonate. Now, because calcium carbonate do not dissolve, so it forms white PPT. Okay, because of the formation of calcium carbonate, it turns white milky. Okay. So what is the
Okay.
pH? pH of the solution Q?
Suggest the pH of the saline
Greater than 7.
greater than 7. Okay. Alkaline.
Write a symbol of the write a symbol equation for the reaction of calcium with cold water. So we have done this one. So write all these chemical equation that we have written here. One is reaction of Q with water, sorry, carbon dioxide to form calcium carbonate.
Ca plus H2O gives CaOH taken twice plus H2.
Yes. Next. Do the next one.
Wait, where? I can't see.
No, no, I'm saying that write the next one. Like CaOH whole twice when react with carbon dioxide will give you CaCO3 plus water. Write that equations. This equation.
Okay, okay. Nice. Done.
Next.
Magnesium reacts with chlorine to form magnesium chloride, MgCl2. Magnesium chloride is an ionic compound. Complete the dot and cross diagram of the ions in magnesium chloride. Show the charges on the ions. MgCl2. So, wait.
What is the atomic number of calcium?
Calcium. Atomic number of
Sorry. Atomic number of magnesium.
magnesium. I think, wait. It was 13,
No, it is 12.
7,
12, 12.
12.
So let me show you.
And chlorine
That
is 17.
yes,
13.
magnesium is going to have 2 8 2 electronic configuration, and it is going to have 2 electron in its outermost shell. Its structure is like this: the 2 in the first shell, and then 8 in the second shell. 1 2 3 4 5 6 7 8, and then 2 in the next shell. 2 in the next shell, last shell. Okay, last shell. So, but you know that its nearest noble gas for magnesium is neon. Neon, which is Ne, noble gas, it is going to have electronic configuration 2,8. Similarly, chlorine, which is going to have 7 electron in its outermost shell, 1 2 3 4 5 6 7. Another 1 2 3 4 5 6 7. So this chlorine atom is going to have 287 electronic configuration. 287, 287.
Also, it needs one more electron to be balanced.
Yeah,
So it
so
will
it will,
join.
yeah,
So magnesium will give the electron in its outermost shell, the two electrons, each
yeah.
one chlorine.
So it will become 2 positively charged.
Yes. And
So yeah,
chlorine will get minus
so
2 charge.
it is 2 electron has been donated, given out.
Yes.
And now the chlorine atoms will gain, chlorine atoms will become 288. this will be 8 electron, 1, 2, 3, 4 in the outermost shell, in the last shell. Okay, and they will going to have acquired -1 negative charge because they have accepted 1 electron, and if they are accepting the 1 electron, so it will be negatively charged. Understood? Yes or no?
Yes, understood.
So here we will simply say that here they are transferring one. No, they have already transferred. So same in the questions of yours. Here we have to represent. So there is already chlorine is going to have magnesium is going to have only first shell. So when it
We
donated,
have
it
to
should
draw the shell for magnesium. We have to
yeah
draw that.
one extra shell. 1,
So
2,
now 8.
3, 4, 5,
Yes,
6.
don't draw the outermost shell because it's already given away.
Not
And
the
charge,
not charge what charge?
the charge on magnesium is -2.
+2 because it has donated.
If you donate minus, right?
Yeah, because if you have removed the negatively charged particle from your, so then it will become positive, na?
So magnesium is +2. Chlorine will gain minus charge.
Yeah, chlorine will get -1 charge and here also -1 charge, but here one shell is missing, na? It's going to 8. It will become 288. 288, na? So one shell here.
288. I draw an extra shell. We have to do that like if it comes in exam.
Yeah.
Okay.
Take the screenshot of this question. This is important. Just a minute. Take the screenshot.
I took.
You took
Yes.
very fast.
Just press print screen and
Name one physical property typically of ionic compounds such as MgCl2 that is that they are soluble in water, i.e. is they are soluble in water.
okay. These are the two properties, physical properties that are typical of ionic compounds.
Tell me
They're
fast.
soft. They're soft.
Hmm?
They're, they're soft. They break easily.
No, they are ionic compounds are tightly held together with a strong electrostatic force of attraction that I explained you, that is 10 to the power 39 times than the gravitational force. And large amount of energy. I think what I have teach you in India, you have left it along with it. No, I'm not going to
No,
take,
no, no.
you bring it along with
Yes.
you in your brain. Actually,
They
when
are,
the
so they are very.
yeah, this is very simple that actually, let you write it, please. The ionic compound, just a minute. Uh, properties of the ionic compound, and ionic compounds are actually the compound that are formed uh, by gaining or losing of electrons. Okay, the ionic compounds are formed by transfer of electron, and typically they occurs between metals and non-metals. They have high ionization, they have low ionization energy, so metals can easily lose electron, and non-metals have high electron gain enthalpy. They can easily gain electron affinity. So we can simply say that the ionic compounds, actually, if I'm talking about their properties, so ionic compounds are having highly electrostatic force of attraction. Like you see here that if I'm going to discuss the structure of sodium, sodium easily loses 1 electron and attend the stable electronic configuration of that of neon to 8. Okay, when it loses one of its electron. Now sodium is happy, nothing to do with chlorine. Okay, and chlorine accept that electron, and chlorine is also happy. They can individually live together because they have attained the stable electronic configuration. But
Yes.
still they are combined together and they are in solid state just because they are they are hold with a strong electrostatic force of attraction between them. Okay, they are hold with a strong electrostatic force of attraction. You understood?
Yes.
So this is the reason that ionic compounds have very high melting and boiling points, and moreover, they do not conduct electricity in the only conduct electricity in the aqueous or molten state. but not
Okay.
in the solid state. Why? Because in solid state, they are tightly bonded and they are not free to move. Okay, note down the properties of ionic compounds in your notebook, please. First read it thoroughly and memorize and try to memorize it. And also the solubility. Ionic compounds are soluble in polar solvent only. Polar solvent like water. They are not soluble in non-polar solvent like petrol, diesel, oil.
Yes. High melting point and boiling point, electrical conductivity, solubility, and crystal data structure.
Only the headlines.
Yeah, I will tell the
Okay, just
one
write
compound.
These are very simple. Just you have to write these two in detail. Other you leave. Other you write only this. Any compounds are soluble in polar solvent like water, but insoluble. So you have to write it up to here. The whole. Don't write it. I have a copy of yours, Nabeel, and is that having the 32? Uh, you are having 18.5 marks. When does
Wait,
this test? When does this test occurs?
which one? Which one?
Today I got your copy. I'm having your copy. No, this is from Mohammad Rihan.
Hmm.
Name Mohammad Rihan, class.
Class which?
Okay.
Who you got copy from?
I got means that academic means they have given me some. Yeah. You done?
No. And
Okay. Tell me E part.
Aqueous silver nitrate is added to aqueous magnesium chloride white precipitate form. Write ionic equation for this reaction. Includes state symbols. Aqueous silver nitrate. AgNO3. Ag3 plus MgCl2. Give AgCl2. AgCl2 and
First of all, tell me the compound formula for the aqueous silver nitrate.
AgNO3.
Okay, when it react with,
MgCl2.
then it will gives you
MgCl only. AgCl2 plus
AgCl, not AgCl2. Both has
AgCl
one valency. Ag has one valency and Cl also has one. Plus
plus uh, Mg2NO3
magnesium has valency 2 and nitrate ion has valency 1. What should be the formula?
and it's opposite. MgNO3 taken twice.
Which of the following is going to form white precipitate?
What?
White precipitate forms. Which of these are going to form white precipitate?
What precipitate? Magnesium.
Magnesium. No. The less reactive metals form the precipitate. Here silver and magnesium. Among silver and magnesium, silver is less reactive. So it is going to form precipitate. We'll write arrow or we can write it S or we can write it S solid.
Okay.
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 Note
So
this reaction.
less reactive metals form precipitate.
Yeah. Note it down fast.
Yes.
Done.
Yes. Done. When copper 2 oxide is heated at 800 degrees Celsius, undergoes the react. Wait, what do I have to do?
Copper is a transition metal. It is a variable oxidation state. The chemical reaction of transition metal, which make different from group one element. No, it is not from your chapter that we have. Yeah, this is a reaction when you are heating copper. Okay, copper oxide. It will gives you. Identify the substance that is. Identify the change in the oxidation number in copper and oxygen in this reaction. Copper and
Oxy.
oxygen oxidation number change. Tell me fast. It is very simple.
It increases the oxidation number.
change in oxidation number from of copper from copper here. If I'm having copper CuO,
4 oxygen.
so what should be the oxidation or charge on copper right now?
C4 CO. 4
Oxygen
oxygen.
yeah, here the oxygen is having 2. So here the copper should be 2, na? Plus 2 and
Yes,
minus.
it's
So that
2.
it will cancel out each other and have formula Cu.
CuO
But in
plus
Cu,
CO2.
but in Cu2O,
It can't.
hmm?
1 oxygen. Oxygen decreases.
No, oxygen is fixed. So it should have 1, na? That's why it's you cross multiply. So it should be Cu2O.
Okay. Wait.
Or if you are not done with this one, so you can consider as copper as X. And how many copper atoms are there? 2. So you have to write here 2x.
Okay.
Okay. And then oxidation state of copper oxygen is -2. And there is 1 oxygen. So you write 1 is equals to 0. There is no charge. So it is 0. Now this 2 will goes to that side. So you will get 2x is equals to 2. Then x is equals to 1.
Okay.
So
And
here is 2. But when it goes to this side, it become +1. So here is +2 from +1 to +2. From +2 to +1. Copper is going from +2 to +1. Okay.
yes.
But here is -2 for the oxygen. But I have told you that when an element is in individual state alone, then its oxidation state becomes 0. And it is written alone, then its oxidation state becomes 0. So here it will be 0. So it is
0.
going from -2 to 0.
-2 to
Can you
0.
tell me that in which case the oxidation is taking place and reduction is taking place?
In plus 2 -2. In second one,
Oxidation or reduction?
oxidation,
Or in the first one?
reduction.
Why?
Because first one is second one is oxidation, right?
Might
So
be.
minus
First you need to
0,
answer me why it is so.
-2 to 0.
Increase in oxidation number is oxidation. Like -2 to 0 is increase. So it is oxidation.
Yeah.
Understood? And decrease in
This
oxidation
one
number
is
is?
this one is decreasing.
Yes,
So it is
decrease in oxidation number is?
reduction.
Very good. It is reduction. Explanation?
For what?
That why it is increasing or decreasing. You can give it. Okay. Now, next.
Calculate
Calculate
the.
the volume of the gas measured at RTP.
We didn't do this.
Okay, we have not done this one.
Copper metal is obtained from scrap iron added to aqueous copper.
It's very simple. Tell me.
Hmm?
This is a very simple reaction. Tell me.
Copper metal is obtained when scrap iron is added to aqueous copper to sulfate. The reaction between iron and aqueous copper to sulfate is a displacement reaction. State why this displacement reaction takes place. Is obtained when scrap iron is added to iron and aqueous copper to sulfate.
What is the formula for copper sulfate?
Yeah, reaction. Huh?
What is the formula for copper?
Cu2SO4. Cu2SO4.
Cu2.
Copper 2 sulfate. Wait, no. CuSO4. CuSO4 only. CuSO4 plus Fe2.
Not. It is a metal. It is written alone. Fe. Then it
Fe,
will give you.
uh, Fe iron sulfate plus copper.
Yeah, it will displace because
Oh,
and white
because
is
copper is less more reactive than iron.
no iron is more reactive than copper.
No,
So that's why
copper is less reactive than iron.
we will write that iron is
Less
more
reactive
reactive.
metal gets displaced.
Yes, note it down fast. You have to use your pencil and pen so that your memory will become more efficient. Okay.
Yes.
Okay. Next, write a symbol equation for the reaction between iron and aqueous solution of copper sulfate.
Oh, simple equation. Like this one we wrote above.
Yes.
Isn't that the
Yeah, we have done this one. Now the next, a displacement reaction is one method for obtaining copper metal and from aqueous copper sulfate. Identify the another method for obtaining copper from the aqueous solution of copper sulfate. When you add zinc, you can
and we didn't do that.
next.
Define term acid. Sulfuric acid is from a defined term acid. Substances that dissociate in water to produce H plus ions. They
Very
are
good,
protons.
very good.
Define
Ta-
term strong acid. Uh, sub acids that dissociate that completely dissociate in water to form H plus ions.
It comes completely dissociate H plus ions in acid. Okay, very good. Sulfuric acid is used to make salt known as sulfates. Okay, add an excess zinc carbonate for a sulfuric acid until the reaction is complete. Filter the mixtures and heat the filtrate until the saturated solution forms. And now allow it to crystallize. Okay, suggest two observations that will show the reaction is complete. And first, okay, yes, tell me.
And just two observations which show
What
that
would
the
happen when H2SO4 is added to zinc carbonate? Write down a reaction for it.
zinc carbonate ZnCO3
Zinc carbonate.
ZnCO3 uh, plus zinc carbonate H2SO4 gives me ZnSO4 plus CO2 plus H2 H2O.
Plus CO2 plus H2. Very good. And H2O, CO2 plus H2O. So how will you identify that the reaction is completed?
We
That There,
identify.
there will be no production of carbon dioxide will be there. No evolution of carbon dioxide gas.
Okay. State why it is important to add excess of zinc carbonate in step 1. Zinc carbonate, excess of zinc carbonate, because the reaction is highly exothermic.
No, in order to proceed it further. Yeah, it is. It is. So that the reaction will start at the faster rate, we can say.
To
Define the
speed up
terms.
the
Yeah,
process.
yeah. Uh, define the term saturated solution.
What saturated solution? Uh, define the term saturated solution.
Yes.
I didn't do this type of question ever.
Saturated solution means that no more solute. The condition is there that no more solute can be added.
Okay. No more. What?
No more solute can be added. Means
Okay.
that is means highly. We can simply
So
say that
that's it. Saturated solution means no more solute can be added. This is
yeah.
how we have to.
And second thing is that when we add excess of H2SO4 to it, it means to the previous one. Uh, okay. In this one, so it simply means that uh, in the zinc carbonate when we are adding it to the excess in excess, so it means that if we are not adding it to excess, then some amount of sulfuric acid will be left. So
Okay.
in order to completely utilize the reactions, we have to add it, okay, in
Okay.
excess, so that all the acid will react and the reaction will react, and there is no more acid remain. And saturated solution means the solution when no more solute can be added. There is a condition that no more solute can be added. Means like for example, if you have a we can simply say that like you add a glass, you take a glass of water, you keep on adding tablespoon of sugar to it. So stage will come that when no more sugar can be added to that because all the space is being occupied. So that condition is called saturated condition. Okay.
Name another zinc compound which can be used to make zinc sulfate from dilute sulfuric acid using this method. Another zinc
Name
compound.
compound which can be used to make zinc sulfate
I don't know for this one.
from dilute sulfuric acid using this method. So another compound, any compound you can take instead of like you can take zinc oxide also. When you
Okay.
react zinc sulfate and you take zinc oxide, it will again give you ZnSO4 plus H2O.
Okay. So any compound can be taken.
Yeah.
So
Next, why this method will not work with barium sulfate and barium carbonate? Because barium sulfate is
this type.
insoluble. Insoluble. Barium sulfate is insoluble, and we can say that, and it does not react. Barium sulfate is actually insoluble in aqueous solution. So when the particles are insoluble, means they are tightly packed and they are not going to react.
Okay.
Okay. So note this reaction, please. This one, another compound of zinc.
Yes.
So have you noted that why? Because barium sulfate next in this part, why barium chloride and barium sulfate cannot be used? Because barium carbonate only react means aqueous solution should react. Na? The barium carbonate is insoluble in water. Okay, and so note it down because barium chloride is insoluble. Barium sulfate, sorry, barium sulfate is insoluble in water.
Yes.
Okay, and as a result of which it do not react it completely. It do not allow it to react completely.
Yes.
Almost all the questions that are we have done from this one. Okay, and next we will going to discuss from the rate of reactions. Okay, did you get the assignments for the rate of reactions and the energy transfer from your school?
Rate of
Assignments,
reaction
assignments,
started.
rate of reaction, energy
No
transfers,
assignments. No.
assignments to do,
No assignments from school.
any notes, any some other extra material,
Notes, yes. We wrote rate of reaction notes today. It's complete, up to date till now.
and you have energy transfer notes also.
Energy transfer notes. Yeah, I think. I don't know.
So if you have,
Wait, I have
you
book
send it
over
to,
here.
yeah,
I
if
have
you
book.
have, okay, you can check it.